What if a comet entered our solar system and defied every rule? Imagine an object that seems to break the laws of physics, with a feature that looks more like engineering than nature. This isn't science fiction, it's a thought experiment grounded in a flood of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the very boundaries of our understanding. Let's delve into this possibility together. The Chilean frame. It all starts with a single, unexpected image. Imagine an amateur astronomer, much like the legendary Gennady Borisov who discovered the first confirmed interstellar comet from his backyard Margot Observatory, peering at the sky from the clear darkness of Chile's Atacama Desert. The date is October 20th, 2025. Her equipment, a 150mm refractor, is pointed at the coordinates for a newly tracked interstellar object, 3I/Atlas. What comes back from her cooled CMOS camera after a 60-second exposure isn't a textbook comet. The raw data, captured under pristine, verifiable conditions with atmospheric seeing logged at an exceptional 0.7 arcseconds, shows something impossible. This isn't a blurry social media rumor, it's a hard data point from a credible observer. The coordinates match NASA's official Jet Propulsion Laboratory tracking. The equipment metadata is clean, and the image is perfectly sharp. And there, aimed directly at the sun, is a perfectly straight, highly collimated jet of material. This single frame from a small, converted farm building becomes the most important astronomical image of the decade, kicking off a firestorm of debate and challenging the very foundation of cometary science. Comet Physics 101. To truly grasp how radical this new image is, we need a quick refresher on standard comet mechanics, a model that has held up since astronomer Fred Whipple proposed the dirty snowball hypothesis in 1950. Comets are essentially deep frozen reservoirs of ice, dust, and rock. As they approach the sun, solar radiation heats the surface, causing ices to sublimate directly into gas. This outgassing creates the coma. Then, the sun's constant outward pressure pushes this material away. This pressure has two components. The solar wind, a stream of protons and electrons moving at 400 kilometers per second, which interacts with the gas, ionizes it, and carries it straight back along interplanetary magnetic field lines to form the ion tail. The second component is radiation pressure, the gentle but relentless push of photons themselves, which pushes the larger dust particles away. Because the dust moves more slowly, its path is influenced by the comet's own orbital motion, causing the dust tail to be broad and curved. This two-tail structure is a universal signature. No matter the comet's composition or origin, the rule is absolute. The sun always pushes, and the tails always point away. The sunward jet. Now, let's go back to that Chilean frame. It throws the rulebook out the window. Instead of a fuzzy coma and majestic tails pointing away from the solar glare, the image of 3I/Atlas shows something entirely different. The nucleus is a sharp, dark point. The surrounding coma is strangely faint with a measured magnitude of only 18.5, far dimmer than expected. But the most shocking feature is a narrow, focused column of material, no more than 2 arcseconds wide, extending from the nucleus directly toward the sun. It's not a tail. It's a jet. Seasoned comet observers, like the renowned planetary scientist David Jewett, would find this image deeply unsettling. The expected anti-solar tail is completely missing, replaced by a feature that seems to violate the basic principles of solar-driven outgassing. The object is actively resisting a 400 km/s solar wind. The image confronts us with a stark contradiction. An object that should be fleeing the sun's power appears to be pointing something straight at it. This single observation demands an explanation, and the easy answers simply don't hold up. Breaking the rules. So, how badly does this image break the rules? Completely. The standard solar sublimation model predicts that as a comet gets closer to the sun, it gets more active. Light curve models predicted 3I/Atlas should be at a visual magnitude of roughly +8 by now, but it's hovering around a faint +14. That's a difference of 6 magnitudes, which means it is reflecting almost 250 times less light than it should be. Experts like Dr. Matthew Knight of the United States Naval Academy find this baffling. This implies an incredibly low albedo, or reflectivity, of less than 0.04, meaning its surface is darker than asphalt, possibly coated in complex organic molecules called tholins. Yet, this dark, quiet object is somehow powering a highly energetic jet. A disintegrating comet usually turns into a diffuse, messy cloud, not a sharply defined structure. The object is simultaneously too faint to be considered healthy, and too structured to be considered dead. This is a profound contradiction, exhibiting behavior that seems to mutually exclude itself, and it has left our current models entirely stumped. The gauntlet. Every extraordinary claim in astronomy must survive a gauntlet of mundane explanations. The first suspect is always geometry. Sometimes, from Earth's specific vantage point, dust left in a comet's orbit can create an anti-tail. However, anti-tails, studied extensively by scientists like Michael S. P. Kelly during NASA's EPOXY mission, only appear when Earth crosses the comet's orbital plane. On October 20th, Earth was still over 4 degrees away from the orbital plane of 3M Atlas, making a prominent anti-tail highly improbable. More importantly, anti-tails are always broad, diffuse sheets of dust, not the tightly focused jet seen in the image. The next suspect is a transient event, like a pocket of volatile ice erupting. But these outbursts are chaotic and short-lived, rarely lasting more than a few rotations of the nucleus. The sun-facing feature in the Atlas data is persistent across more than 4 hours of observation, making a fleeting eruption unlikely. Finally, atmospheric distortion is ruled out by the observatory's logs. The stars in the image are sharp, proving the sky was stable. After running the checklist, every conventional explanation falls short of explaining the hard data. Chemical anomalies. If the physical appearance is strange, the underlying chemistry is even more baffling. Spectroscopic analysis of 3I Atlas, led by comet physicist Dr. Jonah Lau, has revealed a composition unlike anything ever seen. The ratio of carbon dioxide to water is nearly 8:1. For perspective, cometary experts like Dr. Mike DeSanti at NASA have shown that for most solar system comets, this ratio is less than 0.3:1. This extreme CO2 dominance suggests 3I Atlas formed in a place far colder and more carbon-rich than our own Oort cloud. But it gets weirder. Preliminary spectra hinted at the presence of nickel, but with a conspicuous absence of iron. This has no known precedent. This might suggest the object formed in a region of a protoplanetary disk where elements were fractionated in a way never before seen, perhaps in the ejecta of a very specific type of supernova. This bizarre, hyper-volatile chemistry might explain some unusual outgassing, but it certainly doesn't explain why that outgassing is organized into a single, stable, sunward beam. It only deepens the alien nature of the object. Retrograde path. The object's path through our solar system is, another major red flag. 3I Atlas is on a retrograde orbit, with an inclination of 110 degrees, meaning it's traveling against the flow of planetary traffic. Its immense speed, with a hyperbolic excess velocity, measured at 32 kilometers per second, absolutely confirms its interstellar origin. It's a tourist here, not a resident, but its trajectory, combined with its estimated mass, raises some really fascinating questions. When scientists like Avi Loeb analyzed the first interstellar object, Oumuamua, its slight deviation in trajectory led to the hypothesis that it could be an artificial object, a solar sail. Now, with 3I Atlas, we have a different anomaly. It's not a subtle acceleration, it's a visible, persistent structure that seems to defy solar forces. This sun-facing jet, in the context of its exotic composition and retrograde path, forces us to consider possibilities that stretch natural explanations to their breaking point. Could this jet be a functional feature perhaps, as propulsion expert Mason Peck has theorized in other contexts, an engineered structure for orbital maneuvering? Perihelion blindness. Here's the deadline. On October 29th, 3I Atlas will reach perihelion, and at that exact moment, it will be hidden from Earth, passing directly behind the solar disk. This conjunction isn't just a scheduling inconvenience, it's a period of total blindness for every ground-based telescope. The sun's glare creates a zone of exclusion for optical astronomy, typically inside about 12 to 15 degrees of solar elongation. This is the one moment when any sudden change could occur completely undetected. Experts on solar system plasma environments like Dr. Geraint Jones know that a powerful coronal mass ejection, or CME, could erupt from the sun at any time. If 3I Atlas were to be hit by one during conjunction, The blast of magnetized plasma moving at over 1,000 kilometers per second could strip material, impart momentum, or even trigger catastrophic fragmentation, and we wouldn't see it happen. It's the point of maximum stress, maximum danger, and maximum mystery, and it's happening when our view is almost completely blocked. Space Watchers. Once 3I Atlas emerges from behind the sun in early November, an army of telescopes will be waiting, the scientific community will be on high alert, and the checklist of what to look for is clear. First is photometry. A sudden jump in brightness could signal a natural outburst, while a steady fade, without a growing tail, would be highly unusual. Next is morphology. Does the comet finally grow a classic anti-solar tail? Or does the bizarre sunward jet persist? Programs like Pan-STARRS, directed by astronomers such as Ken Chambers, are designed for this kind of monitoring and can detect objects down to a magnitude of 24. They will search for any fragmentation, the appearance of smaller companion objects breaking off the main nucleus. Even tiny, almost imperceptible shifts in its trajectory, measured with a precision of milliarc-seconds, will be meticulously tracked by professional networks. Every new piece of data will be scrutinized, compared, and debated by experts like comet dynamicist David Nizvorny. The weeks following the solar conjunction will be a critical test for all existing theories. Emergence. Assuming 3I Atlas survives its trial by fire, its re-emergence in early November will be the moment of truth. Telescopes worldwide will swing to its expected exit path. Veteran interstellar researchers like Dr. Karen Meach will lead campaigns to recover it, looking for even the faintest signature, perhaps as dim as magnitude plus 24. The most crucial measurement will be astrometry, pinpointing its exact position to within a few milliarc seconds. If the jet has been producing thrust, the comet's path will deviate slightly from a purely gravity-driven orbit. Detecting these non-gravitational forces will be the smoking gun that proves the jet is an active propulsion source. Rapid follow-up spectroscopy will be vital to see if its chemistry was altered by the intense solar heating, perhaps revealing new materials boiled off from its interior. The change in the object, or its stubborn lack of change, will be the key to unlocking this mystery. So, we are left standing at a precipice. A hypothetical object, 3I Atlas, backed by puzzling data from real interstellar visitors, forces us to confront the limits of our knowledge. Is its sunward jet a fleeting natural phenomenon, a sign of exotic chemistry we've never seen before? Or is it something that fundamentally bends the rules of physics, hinting at a purpose beyond natural formation? The period of perihelion blindness leaves us in suspense, but the weeks that follow promise a flood of new data. The answers are waiting out there, in the cold dark of space. What do you think is happening with this object? Let us know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Stellar Tech. A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron, a chemical fingerprint that really honestly defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to: if these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The Nickel Mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid, and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has, broken all the rules. Back in 2017, the first ever confirmed interstellar object named Oumuamua left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object. Perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations like outgassing of hydrogen ice or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas we have a second data point that honestly defies easy explanation. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new. It's ancient. Over 5,000 years ago, in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Gertze cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds, they create conditions perfect for the R process, a rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There is another natural forge in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. Not all stars die in neat spherical explosions. Some rip themselves apart in lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example. X-ray maps of W49b from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, well, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. If nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. If 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking, some serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby is, well, astronomically low. His calculations put the odds at about 1 in 20,000 or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes, on a trajectory that seems too precise. The parallel is, honestly, striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor, it's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. If 3I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered, violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Simply Science. What if a message from the stars wasn't a radio wave, but a silent flash of light speaking the oldest language in the universe? On October 13, 2025, an interstellar object, thought to be long gone, sent a signal that defied all known physics. It wasn't random noise. It was a mathematical pattern, the same one that shapes galaxies and life itself, detected by two observatories on opposite sides of the Earth at the exact same moment. Let's explore this together.
The Night of Pulses.
What happens when the sky blinks in perfect rhythm? On October 13, 2025, at exactly 2:41 UTC, that question became terrifyingly real. The Cerro Tololo Inter-American Observatory in Chile and the Mount Abu Infrared Observatory in India, separated by nearly 8,000 miles, recorded the same impossible event. Three faint rhythmic bursts of light emerged from the darkness behind the sun. The source was pinpointed to the trajectory of 3I Atlas, an interstellar object that had disappeared from view weeks earlier. These weren't random flickers. They were structured, appearing in both optical and near-infrared bands, suggesting a controlled emission rather than a natural reflection. As Dr. Seth Shostak, a senior astronomer at the SETI Institute, has often said, a signal that is deliberately structured and information-rich is hard to explain away as a natural phenomenon. On their own, the pulses could have been dismissed as instrument noise or cosmic ray hits, common artifacts in astronomical data, but appearing identically at the same moment in two independent observatories, removed all possibility of coincidence. The synchronized detection transformed a potential error into a verified observation, forcing a re-evaluation of what was possible. The sky went silent, then it blinked, and the world was never the same.
Fibonacci sequence.
Is there a language any intelligence in the universe would understand? The answer is mathematics, and the pulses from 3I Atlas used one of its most elegant dialects. The intervals between the bursts were precisely 5, 8, and 13 seconds. This isn't a random set of numbers, it's a core section of the Fibonacci sequence. 0, 1, 1, 2, 3, 5, 8, 13, the famous pattern where each number is the sum of the two preceding it. First introduced to the Western world by the Italian mathematician Leonardo of Pisa in his 1202 book Liber Abaci, this sequence is nature's architectural blueprint. It appears in the spiral arms of the M51 Whirlpool galaxy and governs the principle of phyllotaxis, the arrangement of leaves on a plant stem, which often follows Fibonacci ratios to maximize sun exposure. The 19th century mathematician Edward Lucas, who gave the sequence its modern name, studied its properties extensively. The use of this sequence suggests a message designed to be universally recognizable as non-random and biological or structural in nature. For an interstellar object to emit signals matching this pattern was profoundly strange. It was as if it was broadcasting a page from the universe's own design manual.
Double confirmation.
How do you turn an anomaly into a fact? You get a second, independent witness. That's what made the 3i Atlas event impossible to dismiss. One observatory seeing strange flashes is a curiosity. It could be a bird, a satellite glint, or an equipment malfunction. But two observatories, on opposite sides of the planet, with different instruments and different atmospheric conditions, recording the exact same pattern signal within 0.04 seconds of each other. That is data. At Cerro Tololo, the sensors logged the bursts at precise Fibonacci intervals. At Mount Abu, the thermal imaging array recorded identical spikes, confirming the event occurred across multiple wavelengths. The odds of this happening by chance, from cosmic background radiation or simultaneous instrument failure, were calculated to be 1 in a billion. As the great astronomer Carl Sagan taught us, extraordinary claims require extraordinary evidence, and this dual detection was precisely that. The team systematically ruled out every known terrestrial and orbital source, leaving them with a deeply unsettling conclusion. The double confirmation was that evidence, forcing a stark choice upon the scientific community. Either they had witnessed an instrumental coincidence of astronomical improbability, or something out there was deliberately transmitting a mathematical sequence using pulses of light.
The golden ratio.
What if the message was not just in the timing, but in the light itself? The Fibonacci sequence is directly linked to another fundamental constant, the golden ratio, an irrational number that's approximately equal to 1.618, also known as phi. Back in the 17th century, the astronomer Johannes Kepler marveled at these divine proportions, believing they revealed the universe's geometric harmony. Now, analysis of the 3i/Atlas pulses showed its light wasn't just blinking. Its peak brightness actually scaled with each pulse. The intensity of the second pulse was roughly 1.6 times that of the first, and the third scaled similarly, matching the progression of phi. The physicist Roger Penrose has shown this ratio appears in fundamental physics and the geometry of space-time. To produce such a signal would require a mechanism capable of precise energy modulation, which is, honestly, far beyond random reflections off an asteroid. The energy distribution of the pulses also matched a logarithmic spiral, a form found everywhere from nautilus shells to the arms of hurricanes. This precise scaling across distance, frequency, and intensity simply could not be a random reflection. It had to be intentionally modulated.
The Fatima anniversary.
Why did the signal from 3i Atlas arrive on October 13th? For many, this date was not a coincidence. It was a deliberate echo through history. The event occurred on the 108th anniversary of the miracle of the sun at Fatima, Portugal. On October 13, 1917, tens of thousands of witnesses claimed to see the sun dance, spin, and emit brilliant colors before appearing to plummet toward the earth. Sociologists like Robert Bartholomew have studied the event as a case of mass suggestion and optical phenomena caused by atmospheric conditions, but its cultural and religious power remains immense. It became a cornerstone of faith for millions, a day where the heavens supposedly intervened in human affairs. Now, over a century later, another impossible light show connected to a celestial body took place on the very same day. One was perceived as a divine miracle, the other was recorded as a mathematical signal. The parallel was impossible to ignore, suggesting a potential awareness of our history and myths. A celestial body performing impossible light movements, on the same date, separated by 108 years, felt less like chance and more like a deliberate symbolic act of communication.
NASA's blackout.
When the most powerful eyes on the sky suddenly go dark, you have to ask why. Just hours before the 3i/Atlas pulses were detected, NASA's Solar Dynamics Observatory, or SDO, went offline for scheduled maintenance. The SDO is a workhorse, capturing an image of the sun every 12 seconds, across 10 different wavelengths, and generating nearly 1.5 terabytes of data daily. For it to go dark during such a critical window is, honestly, highly suspicious. Compounding this, the high-rise camera on the Mars Reconnaissance Orbiter, which can resolve objects down to 30 centimeters on Mars, had been inactive since October 1st. Nicola Fox, the head of NASA's Heliophysics division, oversees these missions. The official explanation cited routine calibration overlaps, but for two premier systems to be down simultaneously felt, to many, too convenient. The SDO's atmospheric imaging assembly, in particular, would have been the perfect instrument to confirm or debunk the pulses directly. Its absence created an unfillable data gap, fueling speculation that this was not maintenance, but a deliberate blackout.
Harmonic resonance.
Was the three-eye atlas signal just numbers, or was it a form of music? According to the work of theorist David Sarita, the signal was a frequency map that aligned perfectly with his hyperdimensional solar model. In this framework, the numbers 5, 8, and 13 are not arbitrary. They correspond to specific harmonic resonances within our solar system. The number 5 relates to Earth's orbital position, 8 to a stable interplanetary zone beyond Mars, and 13 to a deep gravitational shell near Jupiter. Sarita's interpretation reframed the event entirely. The object wasn't just blinking a code, it was striking a cosmic tuning fork, creating brief flashes that carried harmonic energy across the vast distances of our solar system. This idea echoes the ancient concept of musica universalis, or music of the spheres, a theory the great astronomer Johannes Kepler dedicated his life to proving in the 17th century. Kepler believed the planets moved in orbits that corresponded to musical notes, creating a celestial symphony. While his specific theory was incorrect, Sarita's analysis proposed a modern version, that the three-eyed atlas pulses were a physical manifestation of the deep mathematical and resonant structure of our own solar system, a structure we are only just beginning to understand.
The Dante connection.
Could a 700-year-old poem hold a clue to an interstellar message? In the 14th century, the Italian poet Dante Alighieri wrote Paradiso. In it, he describes heaven as 9 concentric celestial spheres, with their structure governed by precise numerical and geometric principles. The year of Dante's death, 1321, is exactly 704 years before the 2025 event. Physicist and Dante scholar Mark A. Peterson published a famous paper in 1979, arguing that Dante's cosmos wasn't just concentric circles, but a hypersphere, the three-dimensional surface of a four-dimensional ball. The rhythm of ascent in Paradiso mirrors patterns of growth similar to the Fibonacci sequence. Now, this isn't to say Dante predicted the signal, but that the mathematical patterns of order and growth are so universal they appear in both our deepest artistic intuitions and in signals from the cosmos. The idea that an interstellar signal in 2025 would use the same sequence is, honestly, staggering. It raises the haunting possibility that this mathematical pattern is a universal signature of intelligent design, an archetype recognized across cultures, centuries, and perhaps even worlds.
Observatories respond.
How does the scientific establishment react when faced with the impossible? With extreme caution. For nearly a week after the event, the Cerro Tololo and Mount Abu observatories remained completely silent, consulting with international astronomical bodies. When they finally issued statements, the language was sterile and non-committal. They confirmed the data was real, the timestamps were synchronized, and the pulses were detected. But they refused to speculate on the source, labeling it a non-repeating, transient, photometric anomaly. It was a phrase designed to say everything and nothing, acknowledging the event while stopping short of any extraordinary interpretation. Yet, the data they released spoke for itself. The photometric light curves showed 3 sharp, distinct peaks with perfect Fibonacci spacing. As planetary astronomer Dr. Frank Marcus of the SETI Institute would argue, you must first exhaust all possible natural explanations, no matter how unlikely. But here, every known natural cause, cosmic rays, satellites, instrumental errors, had been systematically ruled out by their internal reviews. The observatories published their findings not with a press conference, but in quiet technical bulletins buried in their archives. But the message was clear. The signal was real, it was verified, and it was now part of the scientific record.
The missing data.
Sometimes, the most important clue is the evidence that isn't there. As researchers and the public scrambled for answers, all eyes turned to NASA, whose silence was deafening. The data from the Solar Dynamics Observatory for the entire period of the 3i Atlas event was missing from the public archives. This was a gap where 1.5 terabytes of crucial solar data should have been. There was no error note, just a void. Edward Tufte, a pioneer in data integrity, teaches that such omissions are often more revealing than the data itself. This silence wasn't limited to NASA. The European Space Agency's solar orbiter issued no comment, despite being in a perfect position to observe. The Japan Aerospace Exploration Agency JAXA also remained quiet. NASA has strict protocols for documenting data gaps from missions like the SDO. The complete absence of such documentation was a major breach of their own standards of transparency. This global information blackout became the smoking gun, transforming the narrative from a scientific puzzle into a potential cover-up. In the end, we are left with a hauntingly simple pattern: 3 pulses of light, with intervals of 5, 8, and 13 seconds. It was a signal that used the universal language of mathematics, broadcasted on a date loaded with historical symbolism, and confirmed by 2 independent witnesses. Yet, the agencies with the power to verify it were conveniently looking the other way. Was 3I Atlas a natural phenomenon so bizarre it mimicked intelligence, or was it a deliberate message from something far beyond our understanding? A cosmic hello from a passing traveler? We may never know for sure, but its journey through our solar system served as a powerful reminder that the universe is far stranger and more mysterious than we ever thought possible. It proved that we are not just looking at the stars, something may be looking back. What do you think 3I Atlas was? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thank you for watching Simply Science.